Here we have a question based on this diagram where we have to find what? We have to find the currents through, right? Currents through the two ammeters A1 and A2. Okay. So how much current we are observing in the two ammeters A1 and A2. Also what we have to find? We have to find the potential at the 2 points M and N. Where are the 2 points? M is here and N is here, right? So we have to find the potentials also as well as the currents. So the given picture is somewhat looking like this one, and be careful. So we are having what? We are having 2 ohm here and 4 ohm resistor here and 5 ohm here and 7 ohm here. So also we are having a 10 volt cell, which is positive on this side, and on this side it is a negative. So, okay, so 10 volts are given. So what the thing we have to observe carefully is the ground connection. So look about this ground connection. We are having a middle connected ground symbol, right? So now what I have to do is in this situation when we are finding the needed things A1 and A2 reading as well as the potentials. So for time being, let us forget about the ground symbol, and we'll rewrite uh, the remaining part of the drawing, which is given. Okay. So what we do is we are rewriting that without, okay, so without having the symbol of the ground, right? So what the thing we are having here? We are having a resistor 2 ohm. Next we are having one more resistor 4 ohm. Next we are having an ammeter A2. Okay, so this is a straight line, straight wire, and we are having 2 resistor 5 ohm as well as a 7 ohm. Okay, so 7 ohm is here, and all the stuffs are written except one more ammeter, that is A1, should be written here. So along with the major power source, right? So what the kind of power source we are having? DC, and how much volt it is giving us? It is of course plus minus and 10 volts, right? So this is about the circuit. Observe carefully, we have not considered the ground symbol. Where the ground was? The ground was here, right? So ground was here, but what I said, so we should not consider this ground symbol. So now we have to find what? We have to find the currents A1 and A2. So first of all, what we have to do is let us forget about the A2 and only consider the resistors of 4 ohm, 5 ohm and 7 ohm first, and later on we are adding these two. Okay, so this 4 ohm and this combination, how much is this combination? These two are in series, right? So in series, how much we get? So these two are in a series. So how much we get? We get 7 and 5 means 12 ohm. We're having 12 ohm resistor here. So right, so 12 and this 4 is parallel. So right, so parallel connection. So for parallel, what we have to do? So we have to calculate like this: 4 multiplied by 12, and in the denominator, what we have to do? We have to consider the 4 plus 12. So right, so how much we get? So it is 4 into 12 divided by some 16s, 4 ones are 4 fours are, and definitely 4 ones and 4 threes are. So we get 3 ohm. 3 ohm as the effective resistance of this loop. Okay, so this loop has a of effective resistance 3 ohm. So later on, what we have to do? We have to add this 2 ohm in series along with this 3 ohm. So now finally series. So final series combination. So for the final series combination, what we have to do? We have to add 2 and 3 effective. So how much we get? We get 5 ohm. Okay, so overall what we got is, let me redraw the same picture one more time with a something looking like this, right? So 2 ohm, and this is our A2, and this is our 5 ohm, 7 ohm, right? 5 ohm and 7 ohm. This one is a 4 ohm, and this is 2 ohm. Of course, let us have the battery and one more ammeter, the battery and one more ammeter. We are having ammeter A1, looking probably like this. Well, so what the effective resistance of the whole combination? The effective resistance of whole combination is 5 ohm. So final value of resistance. So this is our total resistance, right? So this is our total resistance. So now, so using Ohm's law, what we do is, say this is our 10 volt battery, right? So the overall current, where the overall current is flowing in this way. So let us call this our I1. So I1 is nothing but the current which is flowing through this A1 ammeter. So using Ohm's law, right? So we are using Ohm's law. So directly from Ohm's law we get what? I1 equals, it is V by, right, applied voltage divided by R, just total resistance. So total resistance. So how much is our applied potential, which is 10 volt, and we are having how much the total resistance, which is 5 ohm, right? So we will get what? We will get 2 amps. So this is nothing but our current. So this 2 amps is the current is the current, right? Current through what? Through A1. Through A1. So we got the answer for A1. So A1, the current we found, which is 2 amps, no doubt. So what we have to find next? We have to find the current through this one now, A2, right? So how much current is flowing through A2? So we have to find only this one. Okay, so the effective resistance of this branch we already know, right? So this effective resistance of this complete branch, that we know, right? The effective resistance is 3 ohm. 3 ohm is the effective resistance. So using this concept, we are going to find the answer for A2. Okay, so we will do what? We will redraw this picture only for the 2 parallel branches. So here is 4 ohm or 4 ohm, and here is our A2. Okay, so A2 is there, and how much the ohms we are having? So 5 ohm, and we are having 7 ohm here, and this is how the parallel combination would look like, right? So this is the effective resistance is 3 ohm. Definitely it's a 3 ohm effective resistance. So let us find the potential drop across these 2 points. We already know this is N, right? So in the picture we are already given that point as N. Okay, so that point is N, and we will put some different name for this point. It is P. So potential difference between P and N, right? So potential difference between P and N is, so R total, right? So R total multiplied by I1. So what we will get? So we will get, so R total is 3 ohm, which is multiplied by 2, which is 6 volt. So this is nothing but our potential difference across P and N. We got what? We got the potential difference. So potential difference 6 volt is common both for the upper branch. Okay, so potential difference 6 volt is applicable both for the upper branch of this parallel circuit as well as the bottom branch. So 6 volt is common for both. Means 6 volt is the potential difference between the points P and N, and this is an ideal. Let us assume this is an ideal. Otherwise, we won't get any standard answer because we have not given any detail about the structure inside this ammeter. So what we are having now? So we are having only the one branch, that is the upper branch, along with the meter E2, right? So this is, so here is our P and this is our N. And how much potential difference we are having? We are having 6 volt potential difference from this point to this point, and the resistance is only 4 ohm, right? So 4 ohm. So finally, what we have to do is, so we have to do what? We have to calculate the current. So let us say this is our I2 is the current which is flowing through the ammeter A2. Okay, so again using Ohm's law, so we are using the same formula, right? One more time, V divided by R. How much is our V? So the potential difference is 6 volt because this meter is ideal, so having no resistance. So means the potential difference applicable is 6 volt and the resistance is 4. So this is 3 divided by 2, right? So I2 is 3 divided by 2. We are getting I2 is 3 divided by 2 means what? 1.5 amps. So this is the current which is flowing through A2. So 1.5 amps is the current, is the current through what? Is the current through A2. So we got this answer also, right? So we got the current flowing through A2. So finally, what do you have to find? So look in the question one more time if you have forgotten. So we found A1 current, we found A2 current, that is the current that are the currents flowing through the ammeter A1 and A2. Finally, we have to find what? We have to find the potentials at M and N. Be careful, it is potential, not potential difference. It is a potential at M and N. So what I have to do for this is, one more time we must draw the same circuit, right? One more time we will draw the same circuit, but we have to consider the ground symbol now. Okay, so we will forget about the ammeter because we already found the currents. So if I want, I will write only the values, not any A1, A2 symbol. Okay, so this is a somewhat wrong, probably I have written, right? So here is the resistors or the resistors. How much value we are having? We are having a 2 ohm, 4 ohm, 5 ohm and 7 ohm, right? Here is the branch, and we are having the battery. What do we have to write first? We have to write this ground symbol. So now this is 10 volt battery, of course. So what actually the ground means? So ground is a point. So for instance, we shall assume it as a reference set 0 potential, 0 volt. Okay, so this is our ground point G. Let's call this point G, ground. Okay, so point G is what? So point G is our ground. Now what we have to do is we have to consider the two other points. One is M and another one is N. Okay, so these are the 2 points. We already know the main current which is flowing through the point M is 2 amps, which is our I1, right? So I1, how much is I1? I1 is 2 amps. We already know I2, so I2 is flowing here, which is our I2. So how much is I2? I2 is 1.5 amps. So how much current that must flow through 5 volt? So the current through, right? So current through 5 ohm is equals 2 amps minus 1.5 amps, it is 0.5. So, right? So I 5 ohm means the current which is flowing through this 5 ohm is 0.5 amps. Let me change the color of my pencil. So, see the current 2 amps which flows here, and when we multiply that 2 amps with 2 ohm, we'll get the potential across 2 ohm. Okay. So, we'll do what? We'll simply draw the 2 ohm resistor. Okay. The current which is flowing here is 2 amps. So, if I multiply 2 amps into, right, 2 amps into 2 ohm, this is equals how much? It is 4 volt. So, we got what? We got 4 volt here, the potential difference. Okay. Here is this point. So, let me go down first, and here is our 5 ohm resistor. How much current that is flowing through this 5 ohm resistor? We are having only 0.5 amps. So, what I do? 0.5 amps, it is multiplied by 5 ohm. So, we will get what? We will get 2.5 volt. So, the potential difference across this 5 ohm is 2.5 volt. And this is our point G, don't forget. This is our point G, and we are having ground here. So, this is at 0 potential, 0 volt. And on left hand side, we are having the point M. Okay. So, the potential difference, let us find the potential difference. So, potential difference PD across M and G is, right. So, is equals how much? So, this is equals 4 volt plus 2.5 volt. So, this we get 6.5 volt, right. So, 6.5 volt. So, what is actually 6.5 volt? 6.5 volt is the potential difference between ground and the point M. Let me rewrite. So, potential at M minus potential at ground. So, this is equals 6.5 volt. So, what we need actually? We need potential at M. So, this is equals 6.5 volt plus potential at G. So, this is equals 6.5 volt plus 0. Why 0? The potential at G is 0. So, this is equal 6.5 volt. So, this is the exact potential we are getting at M, right? So, we got one more thing. And finally, what we have to find? We have to find the potential at N, right? So, we got what? We got the potential at the point M. So, now we have to find what? The potential at the point N. Okay. So, how to get the potential at point N? This is our question. So, the point is very simple. The current what we are observing flowing through the 7 ohm resistor. Okay. So, where is our 7 ohm resistor? Which is here. 7 ohm resistor is here. How much current that is flowing? Actually, the 0.5 amps is coming in this direction. Observe carefully. The current which is flowing in this direction, right? So, here, let us assume the current is going in this direction. So, this is our 0.5 amps current which is flowing in this direction. Okay. How much will be the potential difference between N and G now? So, that is what we have to find. Okay. So, we will do one more stuff. So, here is our ground. We are having what? We are having the 7 ohm resistor, and here is our point N. For your reference, you can one more time consider the given picture in front of you, and we'll come to know why I have written this part of the diagram. Okay, so the current which is flowing is 0.5 amps here according to our calculation, but in reality, so it is something different. We'll say it later. So 0.5 amps. So what is the potential drop across? So potential drop across 7 ohm is equals how much? It is 0.5 amps multiplied by 7 ohm. It is 3.5 volt. 3.5 volt. Okay, the current is flowing in this manner, right? So current is flowing in this manner. What is the meaning of that? So if the current is flowing in this manner, means we are having a high potential here and low potential here. This is why we are considering 0.5 amps in the right side direction. But according to the picture, so what they have given? So they have given a ground here, right? So this is our ground. Ground is always at a low potential. Ground is always at low potential, which is 0 volt, which is low, right? But the current which is flowing in this direction means what? N is still low compared to G. Okay, so N is at still lower potential than G. Okay, so that is why the potential difference 3.5 volt should be taken negative. 3.5 volt, which is treated negative with respect to N. Okay, so it is minus 3.5 in according to the given drawing. Well, so the potential difference across 7 ohm is minus 3.5. Otherwise, we can simply consider 3.5. Let me say it later. So the potential difference, right? One more time I'm writing potential difference across N and G. Across N and G, this is equals the potential at what? So the potential at N minus potential at G, right? So the potential difference, how much I am getting? I am getting 3.5 with negative sign with respect to ground. Okay, so this is equals, what is Vn? So this is what I have to find, minus what is Vg? It is 0. It is 0. So forget about this 0 then. So this implies what? This implies Vn equals minus 3.5 volt. So the potential at N is also found. So potential at N is minus 3.5 volt. Why we are getting negative? So negative is because N is still lower potential than the potential at G. So that is why we are getting a negative potential. Okay, so that's all about answer. So what's the conclusion then? So finally, the conclusion is very simple. The conclusion, okay, I'm writing the conclusion. So conclusion is A1, A1, which is equals 2 amps. How much is A2? So A2 is 0.5 amps, right? So sorry, so 1.5 amps, I think so. Yeah, 1.5 amp, because 0.5 is the current through the bottom branch. So yeah, the potential at M is 6.5 volt. The potential at N is minus 3.5 volt. So these are the answers. That is what we should consider finally.